Hello, welcome back to your channel of learning mathematics. Today we are going to start with a new chapter of class 9, chapter 7, triangles. So it's a big chapter, it's a geometry portion of class 9. It's kind of a big chapter, but it's a very interesting chapter if you get your basics correct. Okay, we'll have some theorems, we'll have some concepts. So it's a very interesting topic, this geometry portion. Okay, so let's try to learn geometry portion, especially these triangles. So in this chapter, what we are going to do is up to class 8, and even in the previous chapter, we have seen already what is a triangle, isn't it? Everybody knows what is a triangle. But what we are going to learn in this chapter is we are going to learn more properties of some more properties of triangles, which is really going to be very beneficial for us in the future also. So we are just going to add something more extra to our knowledge about triangles. So with this chapter done, a lot of the properties of triangles will be completely known by us. All right, so let's see. It's quite exciting. How many more properties are we going to learn about triangles? New things about triangles. All right, so what is a triangle? That everybody knows what is a triangle. Hey, it's a closed shape with 3 sides, but that's a triangle. It looks something like this. Yeah, it's simple, yes, but as I say, we are just going to be learning some more properties of triangles. We are not going to be studying again of triangles. We are going to be learning more of triangles. All right. So as we all know, a triangle is a closed shape with 3 sides: side AB, side BC, and side AC. It also contains 3 angles, that is angle A, angle B, angle C, and the points A where the 2 sides meet. This is also known as vertex A, vertex B, vertex C. So basically, a triangle has 3 sides, 3 angles, and also 3 vertices. Vertices, those pointed ones, vertices. Alright, so that's basically what is a triangle. So then, of course, as we all know, another property that we learned in chapter 6. What was that? Tell me, what was that? The last part of chapter 6 and all. In a triangle, the sum of all the angles. How many angles? 3 angles. The sum of the 3 angles in a triangle is always 180 degrees. You know that, isn't it? So no matter what, their total of angle A, angle B, angle C should be 180 degrees. It should not be more also, not less. So don't discover anything new again. Alright, it should not be more, it should not be less also. It should be 180 degree. All right, and then triangles can be classified into 2 types with respect to sides, with respect to angles. Triangles can be also classified in 2 types, that is, one is with respect to side and the other one is with respect to triangles. I hope you have brought your pen, paper, copy. Start writing it down, start the chapter well. Notes are very important, so you can start writing down. Alright, so let's move to the next topic, that is a revision topic, that is triangles can be classified into 2 types, by side and by triangles. So let's do a quick recap. In this video, what I'll be giving you is a quick summary of exactly what we are going to learn in this particular chapter. I'll be telling you exactly what are the things that we're going to be learning in this chapter, most of it. Alright. So till then, if you haven't still subscribed channel now, just give me a subscribe and like the video channel. Okay, types of triangles by sides. First one, that is types of triangles, types of triangles by side. We have 3 types of triangles with respect to sides. One is equilateral. Equi means equal. Equilateral sides, equilateral triangle. Second one is isosceles, isosceles, isosceles triangle. Third one is scaling triangle. Array sir, we already know this and all. Yeah, I'm just doing a small revision, only quick revision. Equilateral triangle. What is an equilateral triangle? An equilateral triangle is a triangle in which all the sides are of the same measurement, of the same length. All the sides are equal. 7 centimeter, 7 centimeter, 7 centimeter, 7 centimeter. All the sides are same. When all the sides of a triangle are same, is called an equilateral triangle. It also has, of course, one additional property, which I would also like to just remind you that in an equilateral triangle, the 3 angles are also equal. All of them are actually how much degrees? 60 degree. That's why 60 plus 60 plus 60, 180 degree. So it always has to be 180 degree. Then isosceles triangle. Isosceles triangle was that triangle in which any two sides are same. Any two sides are same, one side is different. Maybe something like 7 centimeter, 7 centimeter, 8 centimeters. So a triangle in which two sides are same and one of the sides is different is known as an isosceles triangle. And the last one is scaling, where none of them are they like each other at all. One is 7, one is very far away, 8, one is very far away, and they don't like at all. They don't like each other at all. 7 centimeter, 8 centimeter, 10 centimeter. All the sides are very different. That's called an scaling triangle. Scaling. Next, the other one is types. Types of triangles, this time by angles. Types of triangles with respect to angles. First one is an acute acute angled triangle. Second one is obtuse, O-P-T-U-S, obtuse angled triangle. And third one is right angled triangle. What is an acute angled triangle? It's a acute angle, everybody knows. What is an acute angle? An acute angle is an angle which is less than 90 degree, more than 0 degree, less than 90 degrees. So acute angle triangle is a triangle in which all the angles are less than 90 degrees. So maybe 60, 50, 70, total to 180, isn't it? 120, 180, yes. So you can see all the angles are less than 90 degrees. So this kind of triangles in which all the angles are less than 90 degrees is known as an acute angled triangle. What is an obtuse angled triangle? It's a triangle in which one angle is greater than in which one angle is greater than 90 degree. Maybe this is 120 degrees. So the other angles will make up the total 180, but our focus is not on the other angle. Definitely there will be now acute angles, but we'll be just looking at one angle only. If it is more than 120 degree, if it's more than 90 degree, if it's an obtuse triangle, yes, it is an obtuse angled triangle. Alright, and the last one that we have is a right angled triangle. A right angled triangle is a triangle in which one angle is 90 degree. Our focus is only on that one angle. One angle is how much? 90 degree. Definitely these two other angles will be acute angles. They will be complementary to each other. They will be acute angles no matter what. But one fixed angle should be 90 degree. Got it? Okay, that's a right angled triangle. So that was a quick recap of what were our basic knowledges concerned with triangles. Now in this chapter, what we are going to learn is this. Congruency of triangles. Congruency of triangles. This is what we are going to learn in this particular chapter in class 9 this year. Congruency of triangles. But what do you mean by congruency? C-O-N-G-R-U-E-N-C-Y. Congruency? Congruency or congruent? What do we mean by congruency? Or like, let's say congruent, C-O-N-G-U-R-E-N-T. Congruent. What do we mean by congruent? Congruent. Yes, it simply means, you can write down, it means equal figures. It means equal figures with same shape and size. It means equal figures with same shape and same size. So that means it's like that same thing. Then that's the meaning of congruent. So we'll be talking of congruent triangles. That means we'll be talking of two triangles which are exactly going to be equal, which are exactly going to be same. The sides, the angles, everything. So when all the sides, all the angles of two triangles are same, corresponding sides, those two triangles can be called as congruent triangles. Don't worry, I'll be telling you more about congruent triangles. Some of you must be thinking, No, don't worry. We are still just beginning only. But before that, we should know, no, congruent means it means equal figures with same shape and same size. Now I'll give you some example like this. See, these two notebooks, you can see that they are very much congruent. They are exactly the same. Of course, color is different, but we're not concerned with the color. Shape, size. Now you can see that if I overlap these two, nothing is left extra, exactly the same. See, perfectly overlapped. That means these two books are congruent. Same shape, same size. Got it? Congruency means that one only. But on the other hand, if you take this, then you can see shape and size also very much different. And if you overlap, see, extra left. So that means these two books are, these two shapes, let's say shapes, not books. Shapes are not congruent. That's the meaning of congruency. Okay, congruent means exactly the same. So, but of course we will be talking of triangles. So some of you must be still thinking, congruent triangles, and then this guy is showing us books and all. No, that was just for your concept. That means, see, if you have two triangles, let's say this one triangle, let's say A, B, C, another triangle, almost looks same. Of course, I cannot draw exactly the same unless I use scales and all. Suppose this was 4 centimeter. This is also 4 centimeter. Let's say this was 7 centimeters. Suppose this is also 7 centimeter. This is like 10 centimeters. Suppose this is also 10 centimeter. Now you will see that, see, these two triangles, their corresponding sides are exactly the same. Now everything is same. Even the angles also may be same. Let's say this is 60. This is also 60. Let's say this is 70. This is also 70. Let's say this is 50. This is also 50. So you can see that this type of triangles, only the names are different. One is ABC, one is PQR. You can see that everything is same, isn't it? Now this kind of triangles are known as congruent. C-O-N-G-R-U-E-N-T. This kind of triangles are known as congruent triangles. Alright? How do we denote? We will be denoting, this is the denotation that we use, that is like equal to and something like a wave, something like this. That's how we denote congruency. Okay, equal to on top, slightly curved shape, S shape, sleeping S shape. So how will we denote? That will be denoted as triangle ABC and triangle PQR are congruent. That's how we will be denoting. Alright, so it's a very simple concept. Okay, don't be confused too much with that. Congruency means exactly the same. Their corresponding sides, corresponding angles, they should be same, exactly the same. As I showed you with the notebook, they should be perfectly overlapping, everything same, angles, sides. Then those two, that's like Xerox copy. In short, Xerox copy. Alright, those kind of triangles are known as congruent triangles. It can be for any shapes also. Congruent squares we can have congruent rectangles, but yes, of course, this chapter will be talking of congruent triangles. So this chapter is about congruent triangles. So now we will be learning more about congruency and congruent triangles. Alright, yes, but beware, sometimes it might not look so perfect like this. Okay, sometimes it might not look so perfect like this, but if you look deeper, then definitely they will be congruent, because sometimes they will trick you. 4, 7, 10, and then they will just trick you. 7, 4, 10. So at the first, so let's say this is 4, this is 10. So at the first look, you will say that this is not congruent, not same. But no, look closely. See, sides are same. One side. This side's same. 7, 7, 10, 10. So you can see that we have corresponding sides. That means I can just redraw that triangle PQR. Maybe I can just rotate and just redraw that once again. In that case, we can have something like 4 centimeter, that is QR. So maybe I'll just write like this, QRP. So let's see. We'll have to, of course, arrange. Okay, PQ 7. QR 4, and PR 10. Now you can see that they are perfectly the same. So for AB is congruent, AB is corresponding part is QR 7 7, BC PR. So that way we can arrange. So what I'm trying to tell you, sometimes they will just trick you by rearranging the order. So that time just look carefully. Okay, 3 sides should be same. Yes, they are congruent. Okay, so that's what we mean by congruency. So it's a very small topic, very simple topic, very simple concept also. Congruence means exactly the same. Now that we have some criteria, criteria, criteria. Okay, criteria for congruency, for congruency, criteria for congruency of triangles. Now, why do we need this criteria for congruency of triangles? Why do we need this? Why do we need this? See, the thing is that, see, if I tell you, I gave you 2 triangles. Are you with me? Okay. I give you 2 triangles, ABC and PQR. Prove that they are congruent. So in that case, I will have to prove, okay, all the 3 sides are same. All the 3 corresponding angles are also same. Then the 2 triangles are congruent. Now, that's what congruency means. Yes, definitely yes. But it's a good thing that we have some criteria for congruency of triangles, which means it is really not compulsory to every time prove that every time all the 3 sides you don't have to prove they are equal, all the 3 angles you have to prove. That means, what I mean is AB equal to PQ, AC equal to PR, BC is equal to QR, angle A equal to angle P, angle B equal to angle Q, angle C equal to angle R. Every time, if the question says prove the congruency of these 2 triangles, or are they congruent, every time you don't have to prove all these 6 conditions. You don't have to prove all these 6 conditions. No, absolutely not. That's why, that's a good thing about this criteria. So we have around about 5 criteria. If you can just fulfill that, then we can go on just to proceed and then just go on and tell that these 2 triangles are congruent. Okay, what are they? Excited? What are they? Chalo, I'll give you that. I'll give you the criteria. Okay, so it is not necessary that every time you have to prove all the 6, that the 3 sides and 3 angles are equal. The first criteria is side, angle, side. I'm just writing it in short. S means, I'll just write, okay, S means side, A means angle. I'll explain one by one, but let us just write on the criteria. First one is side, angle, side. Next is side, side, side. I'm just giving you all, okay, about congruency in this topic itself. So it will be beneficial for us in the second exercise also. Third is angle, side, angle. The fourth criteria is angle, angle, side. Angle, angle, side. And the last criteria is right angle, hypotenuse, side. This one let me write. Right angle, hypotenuse, side. RHS, right angle, hypotenuse, side. So if you can just prove this, anyone, then we can just go on to proceed that the 2 triangles are congruent. That means 2 sides, 1 angle. If you're, of course, I'll be explaining in detail, but briefly. 2 sides, 1 angle, all the 3 sides. Now, if you can just prove any 2 sides, not any, there is a condition. 2 angles and 1 side, or 2 angles and 1 side. I'll also tell about this. Sir, you might be thinking, sir, these 2 is same. No, 2 angles, 1 side. No, there is a criteria. I'll talk about that. But here what happens is, you see, if you can just prove 2 sides and 1 angle with respect to the criteria, 2 sides and 1 angle, then that's enough. That means you don't have to prove 3 sides, 3 angles. So that's one good thing about this criteria. So if you can just fulfill any one of these criteria, then you can proceed and tell that yes, the 2 triangles are congruent. Alright, let's quickly do it. Let's not waste much time. Chalo. If you still haven't liked, give me a like. If you still haven't subscribed, please subscribe. Kindly share also. Chalo, number 1. Side, angle, side. I'll just give you with the help of diagram only, with the help of example only. Okay. Now what do we mean by side, angle, side? It means, you see, suppose we have two triangles. Okay, suppose we have two triangles. See, though we have this 5 criteria now. They are the only criteria, okay? Do not prepare any more new again, or do not discover anything new. Only those 5 criteria. We don't have any more criteria other than that. You have to keep yourself limited within those 5 criteria. There can be other if you go on researching and all, but let's not talk about that. Let's talk about up to class 9 standard only for now. Okay, so side, angle, sides, only those 5. Alright, now side, angle, side means, that's why this system has to be written properly. Side, angle, side. We can very clearly see that means if two sides are equal, not any just two sides. If two sides are equal and the angle included between the two sides. What is the angle included between the two sides? This angle. Between these two sides, that's why it's in the middle. That means if two sides and the angle included between the two sides are equal, then we can just say that these two triangles are congruent. That's why it's called side, angle, side. Angle in the middle of the two sides. It can be like this also. Quickly, it can be like this. If this side, if this side, then what is the angle included? Not this one. This time, this is the angle. So this angle should be also equal to this angle again. Suppose if this angle is equal to this angle, then no, we can't do that. No, we can't do that. It has to be the angle that is included between the two sides. That's why it's called side, angle, side. Okay, alright. What is the second one? In brief, I'm telling you in quick. Nah, why talk too much? Nah? Side, angle, side. The other one is side, side, side. This one though I think you can guess. If all the 3 sides are equal, if all the 3 sides are equal, this side equal to this side equal to this side, double dash means same sides, triple dash means this two. If the 3 sides are correspondingly equal, then yes, they are also congruent. Alright, now what does this mean? This means that, see, if I can just prove for all this, if I can just prove that the 3 sides are same, then automatically they become congruent. Then automatically we can also proceed and just say that, that's what I was telling you, we can automatically proceed and just say that the 3 angles are also equal. You don't have to prove. Angle P equal to angle Q, angle C equal to angle R. This happens automatically now. Alright, so if you can just prove 3 sides are equal, then they are congruent. Once they are congruent, it also proves that their corresponding angles are equal. Same here also. If 2 sides and 1 angle is already proved, then yeah, the 2 triangles are congruent. Once you are able to prove that the 2 triangles are congruent by any one of the criteria, then automatically the other sides and the left out angles also become equal. Alright, I'll tell you about that also, how we shall write. What was the third one? 1, 2, 3. Third one is angle, side, angle. I think now you can guess. Angle, side, angle. Angle, side, angle. Angle, side, angle. A, B, C, P, Q, R. Angle, side, angle. If 2 angles are equal, corresponding angles are equal. If 2 corresponding angles, double dash means this. And the side that includes both the angles, not just any other angle again. That's why angle, side, angle. If they are equal, then yes, the 2 triangles are congruent. We don't have to prove all the other sides and all the other angles. It can happen like this also. It can happen like this also. If 2 triangles, A, B, C, P, Q, R. If 2 angles are equal, this angle, this angle, this angle, this angle, then what is the side including both the angles? This side and this side, not this side or that side or not. Then if 2 angles and the side included between the 2 angles are also equal, then the 2 triangles are also said to be congruent. What is the other one? That is angle, angle, side. Angle, angle, side. Now this one is slightly different. Angle, angle, side. P, Q, R. A, B, C. We're almost done. Please be with me. Come on, you can do it. Yes, in that case, what happens? If two angles, this angle is equal to this angle is equal to this angle, and any one side, this time any one side, angle, any one side are equal, then also we can say that yes, the two triangles are what? Congruent. Lastly, the last one, almost there. Number 5, we have to finish in one video, no? So that's why I'll need you to be slightly patient. 5 more minutes. RHS, that means right angle. That means we will need two triangles, which of course are right triangles, right angle triangles. Otherwise, not possible. So 90 degree, 90 degree, right angle. Now, how do we see? What do you mean by hypotenuse? Hypotenuse will always be the side that is opposite to that 90 degree. Always remember that. Suppose if this is the triangle, if this is 90 degree, in that case hypotenuse is which side? This side. Alright, and here which side? This side. Got it? Hypotenuse is very easy to identify. Hypotenuse is, and this one will happen only in a right angle triangle. Hypotenuse will exist only in a right angle triangle. So how do I identify that? It is that side in which is opposite, directly opposite to that 90 degree. Got it? Okay, that's called the hypotenuse. So RHS means one right angle, yes, one hypotenuse also same, hypotenuse also same. This suppose like A, B, C, P, Q, R. So angle B equal to angle Q, 90 degree. Hypotenuse AC is equal to hypotenuse PQ, PR, same. And any one side, either this or this. Chalo, this. So any one side BC equal to QR. Then we can say that triangle ABC is also congruent to triangle PQR. That is by right angle hypotenuse any one side corresponding congruency criteria. Then once it is proved that it is congruent, what did I say? Once it is proved that it is congruent, automatically the other angles also now become same. Alright, now, so these are the 5 criteria which we can use. Any one of the criteria depending on the question to prove that two triangles are congruent. Now the last and final topic, that is corresponding corresponding parts of corresponding parts of congruent, triangles. Corresponding parts of congruent triangles. Don't worry, you can just write like this in short: CPCT ... CPCT. Corresponding parts of congruent triangles. What is this? This is, listen, suppose we have two triangles. Okay, suppose we have two triangles ABC, PQR, and then maybe by using side angle side, that is maybe by using AB is equal to PQ, BC is equal to QR, and so the side angle included between the two sides, angle B is equal to angle Q, using this side angle side angle. Using the side angle side congruency theorem, maybe I was able to prove that triangle ABC is congruent to triangle PQR. Yes, of course, we have to first prove that the triangles are congruent, otherwise we cannot use this property which we are studying now. Then what did I tell you? If we are able to prove that two triangles are congruent by any one of the 5 criteria, then we can proceed and then continue to say that the other left out sides and the other left out angles are also automatically equal. That is, angle A equal to angle P, angle A equal to angle P. We can use that result. Angle C is equal to angle R, AC left. AC is equal to PR. Aram, we can just proceed and use continue and tell that yes, those remaining angles, remaining sides are also equal. What property? For what reason? This will be because they are corresponding parts of corresponding triangles. This will be the reason that you will be giving. That means remaining parts, left out parts of corresponding triangles which already become automatically equal. So if you are able to prove that two triangles are congruent, then the remaining sides and the remaining angles which you didn't prove are equal automatically becomes equal. Automatically becomes equal. Property why? CPCT, corresponding parts of congruent triangles. So that is basically the summary of this chapter. Not entire summary. There are some more properties of triangles which we'll be learning. Isosceles triangle property also, that one, and inequality property also, but those are also very easy topics. But this chapter basically revolves around this congruency concept only, especially the first two exercises, the whole chapter. Okay, so I hope you have liked this video. I'll see you with the next video with the first exercise. Alright, so till then, take care and stay safe. I'll be back.